Hi everyone, I'm Joey Chen. I come from F4014. Today I'm going to discuss the concept of differentiation. So we have learned differentiation in the secondary school. We know that an equation or function can be differentiated into the first derivative and second derivative and so on. So the first derivative normally represents the gradient and the second derivative represents the rate of change of gradient. So due to the limited duration, we cannot explain more details. For more information, please reference here. So what's gradient? Gradient is defined as a ratio of changes in y to changes in x. So as we know, for a linear graph, the gradient of a straight line is always constant, but a bit different for non-linear graph. For example, quadratic graph, the gradient of quadratic graph is always changing, keep changing, depends on the x coordinate. So let's say the question asks us to find the gradient of a. How should we do? So we need to apply the concept of differentiation. At first, we need to draw a straight line that passes through point A. Whatever the straight line be, as long as the straight line intersect the quadratic graph. So let's assume the coordinate of intersection point as x plus h. So now we need to find the gradient of straight line by substituting the coordinate of these 2 points. We get this equation. So the value of h represents the small distance between point B and point A. By controlling the value of h, we can know and observe how closer the 2 points are. So for differentiation, we need to get the most accurate value of gradient. So how can we get the most accurate gradient? So let us imagine at what time the point we can get the most accurate gradient. Obviously, when the point B is located at the point A, we can get the most accurate. But we cannot do that. Why? Because when point B is located at the point A, this means no more distance between point B and point A. So the h becomes 0. As we know, the denominator cannot be 0 because it is undefined. So we can apply the concept of limit to limit the h infinitely approaching to the 0. So this equation, so the m is represent the dy dx. That is the first derivative. So this formula is known as the first principle, the basic formula for differentiation. So from the previous lesson, we learned this formula. So this formula can help us to solve most of the problem involve differentiation. For example, question 1, differentiate. The question asks us to differentiate the x power of n. So first we need to let fx equal to x power of n. So substitute the x power of n equals to this formula. So we get this equation. So we need to expand the x plus h power of n by using binomial theorem or binomial expansions. So we get this series of terms. So we found that x power of n can minus x power of n. So we minus it. So get this series of equations. So we found that we can factorize h from each term. So we factorize. So after factorizing the h, so we can divide the h. So we finally get this series of items. So we limit the h infinitely approaching to the 0. So we can just substitute the 0 into the h. So finally we get this as our final answer, n multiplied by x power of n minus 1. So let us move to the question 2. Differentiation involves sin x. So start with the same step. So get fx equals to sin x and substitute the sin x into this equation, become this. This time we use the angle addition formula to expand the sin x plus h. So sin x plus h expand to become sin x cosine h plus cosine x sin h. So we found that sin x can be factorized from this. So we factorize the sin x from this. So next we separate the limitation into the 2 parts. So since sin x is a constant, so we can factorize it from inside the limitation. And since cosine x is also a constant, so we can factorize it from the inside of limitation. So this formula I'm not going to prove because it involves a unit circle. So just need to remember this formula is always equal to 0 and this formula is equals to 1. So by substituting the 0 and 1, we can get the final answer is cosine x. So okay, let us move to the question 3. Differentiation involves non-x. So in this question, we are not going to use the formula given because it can be solved by a simple way. Okay. First, we can let y equals to log x, and based on the definition of natural logarithm, the equation can change like this: e power of y equals to x. So now we differentiate both sides. At the right part, we can use the power rule to solve, and we get the answer 1. And the left part is more complex because it involves the conversive function. So we need to differentiate the outer part first before we differentiate the inner part. So the outer part is y function. So we differentiate the y, become y prime x, and differentiate the e power of y. So we know that differentiation of e power of x is always equals to e power of x. So we get this answer. So now we move the e power of y to the right part. So y prime x is actually same as the dy dx. That's first derivative. So e power of y is equal to x, so we just substitute inside, so we get the final answer. That is differentiation of ln x is equals to 1 over x. As a summary, in this video, we have learned how to calculate a gradient from a non-linear graph and have proven this formula for differentiation, and have learned how to apply this formula to solve the questions. Thank you for watching.